used only once. Half-life, what does that mean? So, what are we thinking? Maybe as a group we can help me out. I guess you're all in your little rooms, which kind of makes life a little difficult. I think there's an easy way. I can put you all back in the main room at once. Breakout rooms, create, return everyone to the main room. All right, there we go. We're all back in chat, which is going to make your lives a little bit messy because you were chatting with your friends, but now you're chatting with everyone again. All right, so half-life. Which answer are we thinking works best for half-life? We have A, B, C, and D. And it's looking like we're going to go with D for this first one. All right, decay curve. Isotope undergoes radioactive decay, a curved line. All right, that's pretty straightforward. Parent isotope, the stable product of radioactive decay? No. The isotope that goes under radioactive decay? Yes. And then the last one must be A. All right, cool. So those are the first ones. We can do those together. Now, the first group, I think was, I forget now, Ava or maybe Abby and Anna. You guys had 5 and 6. Let's just read them, and then maybe while I'm reading them, if you guys want to put your answer for 5 in, and then your answer for 6, and then we'll just double check it, and we'll see how you guys did. So radiocarbon dating can be used to determine the age of which of the following. And our choices are rocks, fossils, and skeleton of a dead bear. And then number 6, after how many half-lives are there equal amounts of parent and daughter isotopes? All right, C for number 5 and A for 6. I like it. So for number 5, you guys don't think that you can use carbon dating for a rock sample. Is there any reason why you excluded a rock from your list? So of course this says radiocarbon dating, which is kind of an important piece of the question. What's the problem with rocks? Perfect. So you went with C, which is the correct answer. Because you can only date things that were once living. And rock was never living. So fossils are good, and a bear, both good. Both living things. I like it. So there you go. 5 was C. Number 6, about how many half-lives are there equal amounts of parent and daughter isotope? So parent is what you're starting with. Daughter is what you're changing into. You guys decided on A for 1 half-life. And that's right, yeah, for sure. So if we drew a graph, our parent would go down like this, and our daughter would be the inverse of that. And where they crossed, right here, would be at 1 half-life. So that's great. So half the substance is decayed, perfect. If half of it's gone, what's the other half? That's daughter. Excellent. Group number 2, I think, was Andrew, Alex, and Taylor, if I'm not mistaken. I'm just going to read through the questions if one of you doesn't mind just throwing whatever answers you guys got in for 7 and 8. Should I nominate someone, or are you guys just okay to pipe up? Maybe Alex wants to throw in the answers that your group got. Number 7, the half-life of nickel-28 is 6 days. What fraction of the isotope will remain after 18 days? Taylor, thank you very much. C and D. All right, these were maybe a little bit trickier than the first 2. I think they did get a little bit harder. Sorry for the last group. 6 days, what fraction of the sample isotope will remain after 18? One thing with questions like this that sometimes students get caught up with is that there's no amount. You're like, oh my goodness, I don't know how much I'm starting with. How am I going to do this question? Well, it doesn't really matter. It's either half of what's there, it's a quarter of what's there, it's an eighth of what's there, it's a 25th. It doesn't really matter what it is. So 6 days, is 1 half-life. We're looking for 18 days. So that's 3 half-lives. So I can draw my little chart, half-life, and then fraction. So 1 out of, get this guy working, 1 out of 1. So if I have 1 half-life, I have 1 half left. If I have 2 half-lives, I have a quarter. If I have 3 half-lives, I have an eighth. And you guys said C, and that was perfect. That made sense, Taylor. That's good. So number 8, the half-life of a particular radioactive isotope is 6 hours. This is a really, really tricky question because you're asked to find out how much daughter isotope is remaining. So if you started with your little chart, half-life, you have parent and daughter. Let's just go with DAU for daughter. If you have 1 half-life, you have 50% parent and 50% daughter. If you have 2 half-lives, you have 25% parent, 75% daughter. 6 hours after 1 day. So 1 day is 24 hours, so that's 4 half-lives. So 3 is 12.5 and 75, 87.5. And then 4 half-lives is 6.25, which is 93.75. So it's asking about the daughter amount, and then you guys decided it was D, 93.75. And you're right. So you guys are all over that. That's a tough question, and these types of questions will come up where you'll just be given a regular half-life question, and then all of a sudden at the end it'll say how much daughter is left or how much daughter was produced or something like that. So you're thinking parent, you're thinking half-life, but clearly you guys were not tricked by that, which is great. The next one was 9 and 10, and I've completely forgotten who was in group 9 and 10. Perhaps Avery and Taylor? How long is a half-life? Every element has a different length of half-life, Taylor. So some things have really small half-lives, some things have really big ones. In the example like number 8, it says it's 6 hours. Carbon-14 takes 5,730 years. Just depends on the substance that's decaying. All right, so the next group was group 3. You guys got 9 and 10. So while I'm just going through them, if any of you want to put the answers in, or if you all do, that's fine. A 24-gram sample of an isotope decayed to 1.5 grams in 48 minutes. How much of the isotope remained after 24 minutes? And number 10, a radioactive isotope has a half-life of 5 days. 8 grams remains unchanged after 20 days. What was the initial mass of the sample? So these ones are kind of working backwards. They've given you some information, and it says, hey, but back a while ago something happened. So help me out with that. So 24 gram decayed to 1.5 grams in 48 minutes. So we have half-life. Maybe I'll draw it down here. Half-life, time, and mass. Okay, so 0 half-life, 0 time has passed. And we had 24 to start. I don't know how long 1 half-life is. That's why this question's a bit tricky. 9 is B, and I think 10 is B, but I have to check that one. And we got A. Abby, number 7 was C. So a sample decayed to 1.5 grams in 48 minutes. It says that how much of the original was remained after 24 minutes. So if we have a 24 gram sample, completely run out of room here, 24 grams divided by 2 gives me 12, divided by 2 gives me 6, divided by 2 gives me 3, and divided by 2 gives me 1.5. So that's 1 half-life, that's 2 half-lives, that's 3 half-lives, that's 4 half-lives. 1, 2, 3, 4. I don't know how much time is passing, but I know I've gone from 24 to 12 to 6 to 3 and then to 1.5. And then it tells me 1.5 grams is 48 minutes. So I have to kind of work backwards and figure out how long 1 half-life is. So 4 half-lives is 48 minutes. So if I take 48 and divide it by 4, that means each half-life is 12 minutes. So the first half-life is 12, then we have 24, then 36, and then 48. So it's asking how much remained after 24 minutes. That's my second half-life. My line didn't line up very well there. First half-life was 12, second half-life was 6, which was B. Definitely a hard question. Kind of a lot of thinking involved there, but these little tables will help you out if you draw them properly. And then for number 10, you guys said, you got A for 9, 10 is B perhaps. Oops. Half-life of 5 days, 8 grams remained after 20 days. What was the initial mass of the sample? So let's do our little chart here. We'll work our way backwards and we'll see how we do. We have half-life, we have time, we have mass. So if we have 0 half-lives, we have 0 time, and we don't know what the initial mass was. That's okay. I have 1 half-life, I have 5 days. I don't know how much mass I had. That's okay. 2 half-lives, I'm at 10 days. I still don't know how much. 3 half-lives was at 15 days. I don't know how much. And 4 half-lives was at 20 days, and I had 8 grams. So if I have 8 grams here, if I work my way backwards, how much did I have here? Well, it's a half-life, so I need to multiply by 2 if I'm going backwards, so I had 16. And then if I do another step up, this was 32. And then another step up was 64. And then another step up was 128. Did I get enough? 1, 2, 3, 4. 1, 2, 3, 4. So I'm thinking it's C, unless I've done something careless. If I go 8, 16, 32, 64, 128. Yeah, you can use the formula for all of these for sure. There's nothing wrong with that. We had group 4, number 11 and 12. Number 9, sort of 10. You can definitely use the formula. 11 and 12, last group, did we come up with answers? I know you guys were working away in there. I think you guys got 11 for sure, but I'm not sure for 12. So the half-life of an isotope is 8,000 years. The amount of that isotope present in igneous rock is only 1/4 of the original amount. How old is the rock? So again, half-life, time, and amount. Those are the things I'm given. Half-life is 8,000 years. So I have 0 half-life, 0 time. I have 1 of whatever I started with. 1 half-life is 8,000 years, and I have a half. 2 half-lives is 16,000 years, and I'm left with a quarter, which is what the question was asking. A quarter of the original. So 2 half-lives, 16,000 years. There we go. And the last one. What is the advantage of using radioisotope with a short half-life for medical diagnostic purposes? The radioactivity is easier to monitor, the radioactivity lasts for a long time, the radioactivity does not stay in the body, the radioactivity induced by the radioisotope is stronger. What are we thinking? Why would we want to use something with a short half-life? When I was a bit younger, I was in a car accident. I had to get a bone scan. And I think they pumped radioactive barium into me. Pretty sure it's barium. And I went to the hospital, they put it in, and then I had to sit there for a couple hours while my bones absorbed it, and then they put me into this big fancy machine, and then they measured the radiation in my bones. And they asked me when I was there, they're like, oh, are you flying on a plane in the near future? And I said, no. They said the next 30 days, I'm pretty sure. I said, no, not flying in the next 30 days. They're like, okay, good, because if you were flying, we can give you this certificate because you're going to, literally, I was radioactive for like a month. So why would we want something like that? For that exact reason. The radioactivity does not stay in the body for very long. So the faster it breaks down, faster it decays, the less radioactive you are, which is a good thing. So there you go. That was the first page. I was going to do the second page as a group, but I think we've run a little bit short on time. So I'll tell you what, I will put the answers up for the second page before the end of the day today. So if you guys want to go through that second page just to kind of make sure you're doing okay with these decay equations, I'll have a completed an answer sheet for this before the end of the day. Probably just after lunch, I'll get that uploaded. And I just want to say a couple more things before we call it a day. Probably don't want to do that. Once you guys finish up Unit 7, there is a Module 2 exam which covers Units 4, 5, 6, and 7. So it's all of chemistry. And I actually went through the exam. I don't always go through them question by question, but I did for this one. And of course, you're going to get a different test than me because it's just drawing from the test bank. But the questions were generally pretty straightforward. Everything was covered fairly evenly through all of the chapters. And it's really important that you guys use your data book. Use your periodic table, use your elements sheet, use the back page with all the radioactive isotope pairs, all those symbols. It's there for you guys to use. You need to be really familiar with it because when you sit down to write your provincial exam, you don't want to be searching for things. You want to just, as soon as you see a question, you want to just say, oh, that's in the data booklet. You want to just be that quick with it, not like, and how about it, and then flip around and things like that. So, so that's, once you're done, Units 4, 5, 6, and 7, you can write that test. So they are the same questions from the test bank from the chapter test, so there's a good chance you'll see some of the same questions you've probably done already, for sure. We're going to start the physics unit on, I forget if we're Monday or Tuesday next week. We'll start the physics unit then. There's two chapters, 8 and 9, and there's about 5 lessons between them. We might take a little bit longer. So there you go. Unit 7, if you could get it done by Monday, that would be great. And if we submit the learning guide for Unit 7, can you get the test word for tomorrow? And the module exam over the next week. When would you like to submit? Okay, so just reading that in chat. Now, Ava, Mrs. Wood, she came to my office a couple weeks ago and she said, Mr. Borden, you need to stop giving these kids test passwords for the weekend because they're just going to do the tests on Friday instead of coming to climbing or whatever the Friday activity is, or sitting at home doing their tests on the weekend instead of going outside and having fun, doing things. So I don't want Mrs. Wood to get angry at me. So I will give you this. If you get your Unit 7 in today, I will get you your password by the end of the day, 3:30. I'll probably be leaving. So if you write the test today, I don't get in trouble, which is kind of the main thing here. Mr. Borden doesn't get yelled at by Mrs. Wood anymore. So I'll give you that. If you get it in by the end of the day today, I can get you the password. But if you don't get it in by the end of the day today, I'm not going to look at it until Monday because I have to work with Mrs. Wood every day and you don't want her to be angry at you, okay? So that's kind of where we're at. You should have Unit 8 printed for next week. If you want me to print you a copy, I can bring it to climbing on Friday, or you can come and pick it up tomorrow or the next day. And there you go. So yeah, climbing is awesome. I used to be a member at the Crux. Did a lot of climbing when I was in university. It was a lot of fun. It's really easy stuff. There's really hard stuff. There's something for everyone. So, well, if you can find some way to come, like maybe down into town a little bit closer, maybe somebody can pick you up. I don't know, but we can figure it out, hopefully, because it's really fun. Climbing's lots and lots of fun. So there you go. I'm gonna leave you guys with that. If you have any questions, I can go over them next day, but I have a feeling most of you guys will be all right. I'll have answers up to those decay equation questions just after lunch today, and that's it for chemistry. You guys survived chemistry, which is great. So you guys get all that stuff done, get that module exam written. 2 chapters left, then we're done for the year. Oh, five lessons and then a little bit of review. So have you guys, hope you guys have a great afternoon. It's nice and sunny out there. Get outside and we'll see you hopefully climbing tomorrow. Thanks.